What's up, little homies? Welcome to 6.3. We're going to be proving lines are parallel. And there is 4 ways that we can prove that lines are parallel. I'll show you what those are now. Now, the first way to prove that two lines are parallel, such as L and M, if alternate interior angles are congruent, then the lines intersected by a transversal are parallel. So let's break that down. So if my alternate interior angles, which we see right here, are congruent, and these marks tell me that they are congruent, well then these two lines must be parallel. Alright, so if alternate interior angles are congruent, then the lines are parallel. So if I wanted to prove that L is parallel to M, L is parallel to M, well, the way I would do that is say that line L is parallel to line M because alternate, what is going on with this? Interior angles are congruent. So if alternate interior angles are congruent, then my lines must be parallel. That's the first way to do it. The second way is if alternate exterior angles are congruent, then the lines intersected by a transversal are parallel. So here's our transversal. Here are our lines, making them nice and colorful. And since our alternate exterior angles are congruent, I know that L and M must be parallel. So I want to prove that L and M are congruent. In this case, well, L is parallel to M because alternate exterior angles are congruent. Alright, that's my second way to do it. Third way, if corresponding angles are congruent, then the lines intersected by a transversal are parallel. So you're getting the point here. So here is my transversal. Here are my lines. Ooh, I'm getting better at this. I am getting good. Look at that. Sweet. Alright, so if my corresponding angles are congruent, then I know the two lines intersected by a transversal are parallel. So if I wanted to prove that L is parallel to M, I would say that line L is parallel to line M because corresponding angles are congruent. And then my last one. This is the fourth way to do it. If same side interior angles are supplementary, alright, supplementary, and remember supplementary means add up to 180 degrees, then the lines intersected by transversal are parallel. So once again, K is my transversal. Alright, we got line L, we got line M, and if you look here, I have these two angles, right? These are my same side interior angles, over here and over here. And if I do 80 plus 100, I get 180. So these two, my same side interior angles, are supplementary. So if I wanted to prove that L is parallel to M in this case, I would say that line L is parallel to line M because same side interior angles are supplementary. And so any of these 4 conditions, if any of these 4 things are true, then you know the two lines are parallel. So let's use this let's apply it. Let's give it a shot. Alright? CH is the transversal for line AD and EH. Now, it might be a good habit to just take out a highlighter and highlight your transversal, one color, and your lines the other. Okay, so these are my lines. Alright. Now what we're given is that we have these two angles, right here and right here, CBD and EFH. CBD is 102 and EFH is 102. Now these two angles would be considered alternate interior. Why am I saying interior? That's exterior angles. We know that from the last lesson, right? And if you look, since they're both 102 degrees, they must be congruent. So I could say, if I wanted to prove that AD, which is this line, is parallel to EG, I would say that AD is parallel to EG because alternate exterior angles are congruent. Alright, that's it. I know they're parallel because the alternate exterior angles are congruent. Let's try another one. Whoop. Whoop. There we go. So in this case, we know that OT is the transversals for line MP and line QS. So let's highlight that. OT, which is right here, is the transversal for MP, and I'm getting real good at this, and QS. Now if you look here, I have these two angles. I have my same side interior angles. Now if I add these up, 98 plus 82, I get 180 degrees. Alright? So if I wanted to prove that NP and QS are parallel, I would say MP, and I'm just using exactly, wow, this is really annoying. I would just say this exact same sentence. MP is parallel to QS because same side interior angles are supplementary. Boom. Proved. Alright? Same side interior angles are supplementary. That means these lines must be parallel. Killing it. Alright. In this one, we know that VK is the transversal for line TW and XZ. So I'm going to take out my highlighter. I think it's really good to just visualize. And I'm highlighting what I got. Alright. Which statement would prove that NP is parallel to QS? If you don't know, that means parallel. Alright, and I'm given these three statements. Well, let's check out to see if any of these three meet the conditions that we learned on the last page. Alright, so let's see. First, our first statement is, wow, this is, what is going on today? Jeez, this computer's acting nutty. You're nutty today. Alright, so our first one says that TUV, which is right here, is congruent to VUW. VUW. Alright, so these two angles are congruent. Does that prove that MP is parallel to QS? Well, these two angles are a linear pair, and nothing that we see on the last page is about linear pairs, right? So this would not prove that they are parallel. No. Alright, get rid of that, actually. Alright, let's try this again. This one says WUK, so WUK, so that's this angle, and ZYV, ZYV, which is this angle, are congruent. Would that tell me that MP is parallel to QS? And once again, it does not, because these are same side interior, and those have to be not congruent but supplementary. So since they're not supplementary, this isn't true, right? It says nothing about being congruent. And let's mark here. The first one was a linear pair. Well, let's try this last one. All right. Let's just erase this guy. TUY, so TUY, which is right here, is congruent to ZYU, right here. Alright, and if you look here, these are alternate interior angles. And if I knew that these two were congruent, then I would know that TW must be parallel to XZ because alternate interior angles are congruent. So this would be our answer. So explain my answer. Well, TW would be parallel to XZ if alternate interior angles are congruent. Alright, final one. Now this is my challenge question right here. This is where it gets a little challenging, right? Because we got all these lines going on. Both P and Q are transversals for line N and M. So I have two transversals now, P and Q. and they are the transversals for N and M. Okay? Now I want to prove that N is parallel to M, and I need to use one of those four conditions. And right now I don't really have much information. So how am I going to do this? Well, there's a lot of ways we can do it, but we know a good way to start would be to fill in any angles that we can. Okay? I just say fill in any angles that you can. So like, let's start over here. Right here I see that this is 86, but since these two are vertical angles, I could also say that this is 86 degrees, right? And if I know this is 86 degrees, I could also fill in this angle right here, because right here we have a linear pair. So I could do 180, let's do it over here, 180 minus 86, and that gives me 94 degrees. Alright, so right here we have 94 degrees. And if this is 94, since these are vertical, I could also say 94. So you see, I'm just filling in angles that I know how to fill in. Now over here, this is a straight line. Oh, right here we have a straight line, right? So I know these three angles must be 180. So if I do 180 minus 12 minus 82, alright, that gives me, well, 86 degrees. So this is 86. Alright, and if this is 86, then I know this is 86. Alright, and finally, well, let's keep going. If this is 82, this is also 82 because these are vertical, right? I'm just using vertical angles. Well, now I have a bunch of angles filled in. So there's a lot of ways that I can prove that it is parallel. The way that I think I'm going to use now is this. If you look here, I can see that corresponding angles are congruent. So where is that? Well, I have an angle right here, right? That's the bottom left, and I have an angle right here. These are in the same position. Since my corresponding angles are congruent, I know N and M must be parallel. Another way you could do it would be to say that I have an angle here, I have an angle here. These are my alternate interior angles. And here, alternate interior angles are congruent, so I know N is parallel to M. So let's just write that in. I know N is parallel to M because, oh, shall we say lines, N parallel to M because, well, let's use the first one we used, corresponding, right here and here, angles are congruent. Done and done. That is a challenge problem. Alright guys, rest of the lesson is all you. By the way, one last piece of advice. Don't ever sneeze on your mom, because you might get her a cold and she needs to take care of you.